Okay, it's recording.
Awesome. Okie dokie. So do you have the document up, the group discussion doc?
I do, and now I have a question. Okay, so I'm recording, but how would I get the recording? I wonder if it'll just go straight to my Zoom account, right?
Yeah, so I think afterwards it sends it to you, like about 30 minutes later.
Oh, okay, cool.
So, thanks. Man, I think you're right about that Gatorade watering down thing, because it was pretty strong.
Try it.
Like, yeah, I'm gonna. It was like, anyway, it's recording, so let's go, but pretty strong. And then I was like, oh shoot, I need water, I need to like drink
Yeah,
something.
okay, next time do it and let me know. Okay, Christian Wood. What percent of the Earth's history passed before the earliest appeared roughly 3.5 billion years ago?
Okay, so I was kind of looking at this already, kind of like what was it asking? And I realized that the Earth was 4.6 billion years old, like is. So if life appeared 3.5 billion years ago, that would mean that life has been on Earth for about 82.6%. So 100 minus that. So that's 17.4.
Also, I have a question. Can you type? Because you're really fast at typing.
Yeah. So I'm going to do the thing.
Then I'll email you this link. Or actually, you can just send it to me if you want.
Yeah. I'm kind of confused though, like what's the difference between the first and second question? Because the first one asks what percent of Earth's history passed before earliest life appeared roughly 3.5 billion years ago. And then based on your answer to question one, what percent of Earth's history was free of life, which would be the same number, right?
Well, didn't you say it was 8.8 billion?
Yeah, so that's how much was with life, but they're both asking without life.
How did you get that 17 though? Wasn't that without life?
That's without life. So
that's how we got it, was by subtracting from 8.
yeah.
So that's
Yep. But I'm confused because the first and second questions are the same.
Huh.
Oh well, continuing.
You're kind of he watches this. Okay. Based on your answers to question 1 and 2, what percent of Earth's history has included life form?
So that would be the 82.6%.
Wait, I see what you're saying. Yeah, that doesn't make any sense because the 1 and 2 are like the same question. Because
Yeah.
if 3 is 80, yeah, I get what you're saying. That is weird.
Whatever. I'm just down to be like, well, it's a goof and move on.
Yeah, there's no rules.
Okay. The first hard fossils are approximately 540 million years old. What percent of Earth's history had passed before this first evidence was preserved? Okay, so we got, I'm just going to write down the number.
Let's see.
So the Earth is 4.6 million thousand. Okay. All right, so the first hard fossils appeared 540 million years ago. So that would be like at year 4 billion 60 million.
A lot of math. Let's see.
Or
What percentage?
so that would be that'd be 88%. And the dinosaurs were wiped out 66 million years ago. No, look at it. The dinosaurs had a pretty long run.
Is it 60?
Okay.
By question 5, Earth's history doesn't mean like living creatures. Is that what it's talking about? Because I'm confused on that question.
Which one? The hard fossils?
The fifth question. Dinosaurs were wiped out 66 million years ago. What percentage of Earth's history has already passed? Is it asking about like living creatures that died before the dinosaurs died?
So that's asking like at what? So pretty much like if the history of the Earth was the timeline on YouTube, you know, at what what second point would the dinosaurs die, and what percent of the video would that be? So I guess that's what it's asking.
I was trying to do my research on it, and I was like confused on what exactly it was asking.
So just for easier math, it's easier to imagine the billion as just being 1,000. Because a billion is pretty much 1,000 million. So it's a lot easier to do the math that way if you want. Okay. So 98%, 98.5%, 6 really, of Earth's history had passed when that happened. And then just the opposite of that.
Oh, so you're just getting the 3.5 billion, take away 66 million? Is that what you're doing?
So the Earth's age, they estimate it to be 4.6 billion years old.
Okay.
So you take that, and then you find out, okay, so if it happened 66 million years ago, then that would have been about 4 billion years ago, and then you just divide it and find the percentage.
I'm sorry.
Okay, so the opposite of 98.6 would just be 1.4%. And then I don't want to pull up the textbook.
I'll pull it up.
I don't know well, but I don't want to.
In your textbook. Canvas. Okay. Quick question. Is our textbook the Mac-Howell practice quizzes?
Yeah, the McGraw-Hill.
Okay. Because I got an email about like just the book itself, and then we got this. And then the book itself, which was online, of course, was like $80, and then this was like, I don't know, I didn't even give me a price on it. So I opted out of the textbook, the actual textbook, and like, I was like, isn't like the Mac-Hill Connect the same thing?
The McGraw-Hill, yeah.
Yeah, so I was like,
But like that's the one that we do the assignments on.
Yeah, so I was like, why do I need to pay an additional $80 when this is already?
Yeah, we wouldn't use it that way anyway.
So yeah.
I don't know.
To me, that didn't make any sense. I was like, Oh, thank you. I already spent like so much money on textbooks for other classes. Okay. Let's see.
Figure 8.24. I'm looking for it.
Let's pull it up. That's loading. Okay, read.
I found it. Okie dokie, this should be useful.
Okay, I finally pulled it up. It's just a chart, right?
Yep.
Oh, sorry.
Okay, so they have 66 plus 145. So that's plus 200, 411 million years. 411 million years. So you got 411 over. So they lived on for 8.9%. Of Earth's history was filled with dinosaurs.
3.8 of history was full of dinosaurs. Is that what you said?
8.9.
Because I I just searched it up and I got 3.68. Because what they did was 167,000 divided by 167 million divided by 400.
You see like the green ones?
Yeah.
So in total, that would be 411 million years.
You're right. I was looking at the ground.
Wait, no, that's wrong.
And then they did divided by 4,540,000.
Oh, because I thought that the number at the bottom of each section was like the length of each section, but that's just like the length of since it happened. That's obnoxious that they don't have that more detailed. Okay, hold on. So it'd be 252 minus 66. Okay, 186. So 186 million years is how long it lasted. That was my bad. I'm sorry.
No, it's really bad.
Okay, so 4%. What was the number you got in the first place?
3 point. I'm so sorry. I just remembered 3.98 something.
Yeah, then you're right. I got confused by the chart. I thought that each number
The
was
chart
like,
is confusing. You have to like really study it for a quick minute.
yeah. Oh, well.
Okay, so next question. What percent? What percent of Earth's history has occurred since the extinction of dinosaurs? So let me go back to the image.
Okay, so I did the math, and that would be 99.9. Wait,
But
so
I did
that's,
get the number because humans is the Neogene period.
yeah.
I'm
So it
not.
says for about 5 million years. So 5 million years. I did the math with the 4,600.
Mm-hmm.
That would be just like 1%, like very much less than 1%.
And what numbers did you get? I mean, what numbers did you use?
So it says that on the earliest human ancestors appeared about 5 million years ago. So we're not using the chart anymore. It just tells us the number.
Oh, I thought you were using the chart. I was like, where are you getting that?
And then I just divided that by 4,600. And
Okay.
then just comes out as like 0.1%. So yeah, percentages. Did dinosaurs and humans coexist? They did not, because dinosaurs the dinosaurs were wiped out 600 or 66 million years ago, and humans only just appeared 5 million years ago.
I know.
All
I
right.
also always thought about dinosaurs got wiped out 66 billion years ago, and like the asteroid that struck Earth was so big that it killed so many large percentages of life because you ever see a dinosaur fossil, it's humongous. And you would have thought if we were living at that time, we would have been completely wiped out because we're so small compared to a dinosaur that size.
Yeah. Yeah, I don't know. I mean, maybe though. I mean, I don't think we could survive an asteroid like that. But
No,
I know that one of the main reasons that like dinosaurs didn't come back
huh.
is that with that asteroid, like a lot of the oxygen on Earth kind of went out. So dinosaurs were so big because there was more oxygen on the Earth before, and they could be bigger boys.
Wow. I would never have thought about the oxygen being an aspect to the dinosaurs being so big.
Yeah. I don't know if that's true or not, but that's what I learned in 6th grade science class. So
That would make sense. Because we're tiny and our oxygen is like polluted
yeah.
badly. But yeah. Huh. That blew my mind for a second.
Okay, this thing about Idaho became a state on July 3rd, 1890. They missed an opportunity. They could have had a July 4th birthday. Anyway, it celebrated 100 years of statehood on July 3rd, 1990. If the average generation interval of a family is 30 years, how many generations of humans have come and gone in 100 years since Idaho became a state? That would be 3.3, because 30 times 3 is 90, and then that would be 1/3 with 10. So 3.3 generations.
Quiet. Do you live in Idaho?
I do not.
Okay. Either.
I'm going to LDSBC, but it just kind of
No
like
way! I'm going to LDSBC now too.
Yay! I don't know why like this geology class is through BYU Idaho, but it's kind of weird because I'm in all of my LDSBC stuff, and then they're like BYU Idaho.
Oh my
And I'm
gosh,
like,
yeah,
oh.
and the canvas is so different. I have to like double check my canvases twice because it's different. I don't like it.
They also like started at a different time. So,
Right? Oh my goodness.
so like my first week, I just died because I was just so lost.
That was me. And then I have a site class through BYU Idaho as well. And she was sending it to my BYU Idaho email, which I didn't even know I had. But
Yeah.
apparently she did. I was like, oh, I'm so sorry. Like, I'm an LDSBC student. I don't receive those emails. She was like, oh. I was like,
Yeah. So like I have an A in all of my other classes because, like, school is my life right now.
I feel that.
But right now, I think I have a C in this class just because that first week, like all the important stuff.
The first week killed me. I have a C in this class right now. I have like a 77. But I'm pretty sure if I just study for this exam that's coming up, it's going to go up to 80.
Like the study project, I didn't even know that we were supposed to sign up for one. And then one day I just kind of like see it and I'm like, oh, wait, what is this?
Me too. I was so lost the first week and it wrecked my grades. Horrible.
Yeah. Oh, well. At least our
What are you
grades now.
studying?
So I'm just doing generals right now.
Oh.
But I'm going to transfer to UVU and do electrical engineering. But
Are you getting your associates in science?
what?
Are you getting your associates in science?
I don't know yet. Oh no!
I was asking because I have to take this class to get my associates in science. So I just assume.
Oh,
I
okay.
transfer as well.
But don't worry, because I guarantee your grade is not as wrecked as that other guy that is in our group that has never showed up.
I bet. Those 10 points add up.
Yeah. Anyway, continuing.
Anyways, yes, I
I
tried.
want to go tonight.
11.
Using the current year, how many generations of humans have come and gone in the total time since Idaho became a state? Okay, so that's just 30 more years. So that would be 4.3 generations. Because 1990 plus 30 is 2020.
Now it says use the same average generation for 30 years.
Many anthropologists believe that humans first migrated to North and South America after about 13,000 years ago. How many generations of humans have come and gone since the Americas were first populated? Well, you take 13,000 divided by 30. 433 generations. And a third. The Yellowstone caldera catastrophically erupted about 640,000 years ago and covered much of North America with deadly volcanic ash. If such an eruption occurred today, millions would perish instantly due to the eruption. Countless millions around the globe would perish because the ash cloud would block sunlight and affect climate and food production. How many generations of humans could have theoretically come and gone during the time frame that occurred since that catastrophic eruption? Okie dokie. Just the same thing, divided by 30.
Yeah.
21,333 and a third generation.
Recall when our earliest human ancestors appeared. Assuming the average generation of interval of a family has been 30 years, has always been the same, how many generations of humans could have theoretically come and gone since the appearance of our human ancestors?
Okay, so they give us
Theoretically. I can't say that correctly.
so they give us an estimate of 5 million years. So divide that by 30, and we got 166,666.6 repeating generations. So that means if evolution is true, you've got 166,666 humans between you and a monkey.
Crazy.
Now you know. Crazy. Okay. Assume an average sedimentation rate. The sediment is deposited of 3.32 centimeters per 1,000 years. How much sediment has been deposited since humans and our human ancestors have been around? Okay, so we got 5 million again, and then you divide that by 1,000 times 3.32 centimeters. That would be 16 meters, 16.6 meters.
What is approximately 3.3 feet? Convert your answer from the previous question into feet. And it was 16.16 million feet. Wait, what was the number you got?
So 16.6 meters.
Okay, so I just did 16.16, right? And 1 meter is approximately 3.3 feet. So that would be 54.78 feet. So what you got?
Let me check. So, hold on. Yeah, because it'd be like
16.6 times 3.3.
4.78. You're right.
Okay. Using the height of one member of your group, how many of that group of these questions, how many of that group member would we need to stack on top of each other to equal the thickness of a sediment?
I am 5'8". So, yeah, Quinn, 5'8". Let's just find out how much 78 would be. 0.78, 12. So that would be 54 feet and about 9 inches. I don't think we need to go deeper than that. So I being 5'8", I'm gonna do some matharoos here. Okay, so I'd be 68 inches tall. You could stack 9.66 of me. To make a sediment that lasted that long. So I wrote 9.66 quins to match an ancient sediment wall. I don't like the thought of the 0.66 though, because I don't know what that means.
Oh, I was actually talking about that in my religion class yesterday, actually. That 7 is with God, and then 6, that's just one less with God.
Not so much that, but any decimal really, because I don't want to know. I want to know what what 0.6 or like what 2/3 of me looks like.
Just like one on.
It's like cut me off. You know? Assume a constant ubiquitous erosional rate of 25 meters per every million years. How long would it take to completely remove all record of humans and their early human ancestors from all geologic time? Okay, so if we found so I assume that we have to like use the 0.16. Okay, so the 0.16.6 meters. Times 1,000,000. 664,000 years. Yeah, so we'd be wiped out pretty quick.
Yeah.
You know, but even if it was eroded and everything, like there's Nokia phones, so those don't erode. Those would just stay there forever.
You are right.
Okay. Using the same sedimentation rate given earlier and assuming that the Earth has had a constant deposition of sediment, how many meters of sediment could have been deposited since the Earth was formed? Okay, so let me just find out. 1,000. Okay, so that would be pretty simple to find out because 3.32 centimeters for 1,000 years, you just add 3 zeros to that to the years to get million, and that would be just a unit. And then so you just add the same 3 zeros to the centimeters, which would just make it meters. So you just convert the centimeters to meters, and then times that by 46,000. By 4,600. Times. Wait, am I right? No. No, that's not right, because that'd be 10 meters. Let me just see that.
Wait, which one? Which question are you solving again?
No, I'm just like, I'm on the using the same sedimentation rate. I'm just making my life easier and making the math more simple to figure out.
Yeah, because I was confused. I was like, where is he getting this number? Okay.
Okay. One, two, three. So, okay, so for 1,000 years, no, for 1,000,000 years, that would be 33 meters and 20 centimeters. So 33.2 meters. And then just times that by 4,600 for the million years. And that would be, we're gonna have to convert this to kilometers. 152 kilometers of sediment. That's a lot of sediment.
Yeah, I was thinking the same thing.
Okay, just real quick, I'm gonna do the okay, and doing it the other way, just the simple way to do the math, calculating it still.
Okay.
There's fireworks outside. You want to see these fireworks?
Yeah, actually.
Sure, I don't have my glasses.
I don't see anything.
Oh, you see them?
No. No. Oh, yeah! Oh my gosh, yeah, right there. I see it. Oh, you have a nice view.
Yeah.
Where are you? That's a bit creepy, but like
Wait, there's fireworks over there too.
are you in Salt Lake City? Or like
I'm in
Utah?
Linden, Utah.
Linden. Oh, okay.
I wonder if our teacher watches through all of the things completely, and he's just gonna be like, "Oh, they just stopped the lesson to watch fireworks." I'm gonna go grab my glasses because I just see. Hold on.
Serious.
Hold on. Where are my glasses? I can't see without my glasses. I'm sorry. A moment.
It's okay. interruptions.
You know, I'm sure those fireworks would have been really cool if I could have seen them. They're right here. Okay. Right underneath the keyboard. Well, anyway, continuing. That was cool. Not every day just look out your window on May 28th to see fireworks.
Yeah, I wonder what, May 28th.
Yeah, happy May 28th, by the way. Assume a constant ubiquitous erosion rate for 1,000,000 years. How long would it take to completely remove all the sediment deposited from all the geological time?
Yeah.
Okie dokie. Divided by 25. That would be 6,108 million years. Okay. Looks like we're almost done. Two students are discussing extreme news events. Student 1, I hear all the time that the world is ending. It seems like every week there are volcanoes, earthquakes, tsunamis, hurricanes, tornadoes, and other disasters in the news. People are dying left and right due to the wrath of Mother Nature. Maybe something weird is occurring with our planet to cause all these bad things to happen now. And student 2 says, I disagree. The Earth does not have it in for us. Our planet has been changing for billions of years. Natural disasters have always been a threat to Earth's life, but humans are relative newcomers to the scene. So I think right off the bat, the student 2 is right. Because like, what?
Which student?
Student 2. So student 1 was saying that, you know, all these bad things are happening nature-wise because Mother Nature has it out for us. But, I mean, no giant meteors have struck the Earth with us on here so far, so...
I think you're right, too. Student 2, because his argument is our planet has been changing for billions of years. It's true, like the whole question. A lot of our questions in the beginning were dinosaurs, and that was on our Earth, and it changed because of the asteroid. Our Earth does change all the time. That's the other thing with global warming.
So yeah, I think student 2 is right because all of those things have happened before as they happen now, and no. For example, a meteor struck the Earth when dinosaurs were here. That has happened to us. Okie dokie. Reflect on and describe how your perception and understanding of geologic time and the timescales on which Earth processes occur changed from before and after doing these problems. So what did you learn, Elaine?
I learned that the Earth is constantly changing, like what students you said in the scenario.
The Earth
It's constantly changing. And being aware of the changes, honestly, is important. So if knowing history, that's why it's so important to know history. So because history most always repeats, that we know how to prepare.
I think, yeah, I think something that I learned might have been, because I remember that I took geology, all this geology stuff in like 6th grade. And I remember that our teacher just tried to pound it into our heads like how mind-numbingly old the Earth is. But something that I kind of understood here more is that it's actually a lot younger than I thought. Because 4.6 billion years is like a lot of time. But nonetheless, it's still a finite number. It's not infinite. Like it's not just like this number that's way out there and like impossible to comprehend. Like, there's things that we count here on Earth that are more than 4.6 billion. Like there's units and stuff. Like I'm sure that
There is. I know exactly what you're saying.
like the first number that comes into mind is like the US debt, like in the trillions. Like, how many people are there on Earth? Like there's 7 billion people, so there's like, more people on Earth than there are years in our history.
That's crazy that our Earth is so populated.
So I think like I just kind of have that perspective now. Maybe it's not as old as we think, as often as they say, but at the same time, it's stinking old.
I don't know, from my geology class from 6th grade, all I remember is our teacher scaring us, saying that the sun is going to come and certain amount of years and we're all going to burn. And I just remember being so scared. I was like, yeah, okay.
Population of Earth is 7.59 billion.
Mm-hmm.
If all the people on Earth, like we've all lived at least a year, and for all the babies that are part of that number that are less than a year, like there's older people that kind of borrow, like lend them a year. But everybody at least has 1 year. If everybody has at least 1 year of experience, then the entire population of Earth has more years combined than the actual age of the Earth.
That is very true. Are you just considering humans as populations, or are you also considering all living creatures? Because all living creatures.
That's just humans.
This is about the living creatures, and the ones we haven't even discovered yet in our ocean.
Well, all right, we're done.
Yay, that was a lot of questions. 22.
Okay, so I guess you can stop recording. We'll end the meeting, and then on Canvas, I'll just email you the document.
Okay, sounds good, Quinn. Let's see.
All right, thanks. See ya.
No problem. Bye. Okay, not gonna do anything.